In the world of high-performance software, there's a huge battle going on. It's this high-stakes debate over the future of systems programming. And it all boils down to one simple but really profound question: will Rust finally dethrone the long-reigning king, C++? All right, let's just jump right in with a single pretty startling number: 70%. So Microsoft came out and said that's the percentage of all their security vulnerabilities that are caused by memory safety errors. And look, we're not talking about minor glitches here. These are the kinds of flaws that can lead to massive security breaches. And you know what? This isn't just a problem for big tech companies. It's actually become a matter of national security. We're seeing the NSA, the White House, even the National Cybersecurity Agency all sounding the alarm, urging a shift away from languages like C and C++ and towards these memory-safe alternatives. So, to really get why this is happening, we got to take a look at the language that's right at the center of all this.
Okay, so to understand this whole conflict, we first have to talk about the king of the hill. For decades, C++ has been the undisputed language when it comes to raw power and performance.
I mean, think about it. For over 40 years, C++ has been the bedrock for our most important software. The operating system on your computer, those blockbuster video games you love, the financial systems that run the entire global economy, a huge chunk of it is built on C++. And why is that? It's simple, really. It gives you raw, absolutely unparalleled performance, and that super low-level control. But all that power, it comes with a really big catch. There's this fantastic quote from computer scientist Tony Hoare, where he calls his invention of the null reference, which is a super common source of crashes, his billion-dollar mistake. And that just perfectly sums up the other side of C++, the peril.
Okay, so here's the deal with C++. You, the developer, are manually in charge of every single piece of memory you use. That puts a huge mental burden on you. You're constantly having to track potential bugs like memory leaks, where memory just gets lost, or these things called dangling pointers that point to memory that isn't even valid anymore. It leads to these really dangerous, hard-to-find bugs.
So, this long-standing safety gap in C++, well, it basically created the perfect opening for a new language to step in. And that language, with its totally different philosophy, is Rust.
So what's Rust's big idea? It's a concept they call ownership. And the rule is actually pretty simple. Every bit of data has one, and only one, owner. And when that owner is done with the data, the compiler automatically cleans it up. Now, this is a massive shift for programmers because it just wipes out whole categories of bugs before you even run your code. And building on that, you have this system called borrowing, which lets other parts of your code temporarily use data they don't own. You can think of the compiler like a super strict librarian. It makes sure that if you borrow some data, you give it back safely, and it makes absolutely sure that nobody tries to change the data while someone else is reading it. Okay, so let's see how this actually works in practice. On the C++ side, if you assign an object to a new variable, it just makes a copy. Now you have two of them, both valid. The checkout Rust. The default isn't to copy. It's to move. The new variable takes over, becomes the owner, and this is the key part, the compiler makes the old one invalid. Bam! A whole class of bugs related to using old data just gone.
And this slide really drives home the real-world benefit. So on the left, you've got this super common C++ problem. You have a reference to something in a list, right? But then you add a new item to that list. The whole list might have to move in memory to make space. And suddenly, your original reference is pointing to absolute garbage. The scary part? The code compiles. It just crashes later, when you least expect it. Now, look at the Rust side. The compiler is smart enough to see this potential disaster. It says, nope, not going to happen. It refuses to even build the program. The bug is caught before it's even born.
But hold on. The C++ world isn't just sitting back and letting this happen. They're not just watching from the sidelines. They're actively responding to the challenge. And they're choosing evolution, not extinction. So, get this. The C++ Standards Committee is working on a huge new feature for the C++ 26 release. It's called Safety Profiles. And it's a really groundbreaking idea. It's an opt-in system designed to bring those Rust-style safety checks right into C++. But, and this is crucial, without breaking all the decades of C++ code that's already out there. And what are these profiles targeting? Well, they're going after the greatest hits of C++ vulnerabilities. The type profile stops you from doing unsafe conversions. The bounds profile keeps you from accidentally stepping outside of an array. And the lifetime profile, that helps get rid of those infamous null pointer crashes and those use after free bugs. The strategy here is actually really smart. It lets developers bring in this new safety piece by piece. You can just enable a profile for your project, and all of a sudden, old, unsafe code patterns become build errors. But for those tricky, older parts of the code you can't fix right away, you can specifically tell the compiler, hey, make an exception just for this spot. Just look at this example. It makes it so clear. On the left, you've got this dangerous old-school C-style cast, totally legal in normal C++, and the compiler doesn't say a word. But now, flip on that new std type profile. That exact same line of code, it's now a compile time error. It won't even build. This means C++ itself is fundamentally getting safer.
Okay, so we've seen the reigning champ, we've seen the up-and-coming challenger, and we've seen how the champ is evolving. So where does that leave us? Who actually wins?
Well, the data tells a pretty interesting story. I mean, make no mistake, C++ is still dominant when you look at existing projects and jobs. But just look at this trend data. You can see the significant, sustained rise in developer interest for Rust. The challenger definitely has momentum. So the choice here isn't simple at all. It really comes down to trade-offs. C++ has this absolutely massive, unparalleled legacy and ecosystem, and it's actively getting safer. Rust, on the other hand, gives you that safety guarantee right out of the box with some fantastic modern tools. But you have to wrestle with that ownership model at first, which can be a pretty steep learning curve. So maybe the question isn't who wins, because maybe this isn't about one language knocking another one out. The competition itself is the real prize here. The fact that Rust is so focused on safety has basically forced C++ to evolve in a great way. So the real winner here is all of us, everyone who uses software, because the entire industry is being pushed to build things that are more secure and more reliable. And that leaves us with one final thought to chew on. You know, this whole battle between Rust and C++, maybe it's not a zero-sum game. Maybe the end goal here isn't for one language to be crowned the winner, but for the principles of safe programming to just become the standard for everybody. What do you think?